Get started. I'm going to start with reviewing the pendulum lab. And as I mentioned yesterday, what you're going to do with your pendulum lab is you're going to find a string and you're going to put some sort of a mass on the bottom of it. And you're going to end up doing 3 lengths. And what you're going to do is you're going to move your pendulum and you're going to raise it up and you're going to allow it to go back and forth, and you are going to get, okay, that pin is dead. So this is considered 1 period. You go back and forth to the start. So 1 period goes from here to here, and that is a period, and that's the time that it takes for 1 complete swing. Now, because of your and the fact that humans aren't really good at this, what you're going to do is you're going to record the time for 10 complete swings. Okay, so you're going to start with length 1. Say length 1 is equal to 1 meter. You're going to do the time for 10 swings. And let's say that that is 2.5 seconds. And I haven't done this in a while, so I'm not 100% sure. You can use your cell phone to do this, and so you might measure it as 2.50 seconds. Then you're going to come up with the time for 1 swing. So you're going to take that number and divide by 10. So this would become 2.50 seconds. You're going to do that 3 different times. So you might get 2.48, and that becomes 0.248, and then you might get 2.65, and that becomes 0.265, and you're going to get an average period. And this is going to be in seconds. So you'll take those 3 and divide by 3. And that'll give you an average. Okay. You're going to do that for 2 other lengths. So let's say you're going to get a 0.75 meters, and let's say you do a 1.5 meters. And this one is going to say we're going to have it's going to have our average. We'll get that particular thing and we'll get our average. And this will give me an average of say 198, and this one gives me an average of 0.307. So what you're going to do for each length, okay, for each length, you're going to do 3 different times. You're going to come up with 1 average. So I'm expecting to see a data table, I'm expecting to see a couple of data tables. One is going to have your 3 different times. So one data table might look like this. Time for 10 swings. And you'll have time 1, time 2, time 3, time for 1 complete swing. And that's going to be your time 1 divided by 10, time 2 divided by 10, time 3 divided by 10, and then you'll have a time average. And that's the average of these 3. So you're going to get a time average. You'll have one of those tables for each separate length. Now, the period of a pendulum is equal to 2 pi times the square root of the length of the pendulum divided by gravity. In order to find gravity, we want to do a graph. So I'm expecting to see a graph. So our second data table that you're going to have, but we're going to go ahead and rearrange this equation. So I'm going to square both sides. So I'm going to get t squared is equal to 4 pi squared L divided by G. I'm going to do this in terms of L. So I'm going to get an equation of L is equal to G divided by 4 pi squared times my period squared. So my second data table is going to be length, period average, period squared. So my lengths that I just did were like 0.75 meters. I did 1.00 meters and I did 1.50 meters, and I got a time average of 0.198, and that's in seconds. I've got a 0.254, and I have a 0.307. I want to go ahead and square each of those. So this will be like 0.0647, and that's in seconds squared. I'm going to get 0.0392 seconds squared. And I'm going to get 0.0942 seconds squared. To find G, I'm going to have to do my graph. And we've already got my equation. My equation is going to be length is equal to G divided by 4 pi squared is going to be T squared. So the graph that I want to create is a length per time squared graph. You're probably going to want to use Excel. You're going to get 3 values. You want to draw your best fit line. So I'm going to get my best fit line through here. I'm going to get my equation for my line. And so off of Excel, my equation might say y is equal to, and I'm going to make up a number. And this is a made up number. So this is like, we're going to say that this is 1.36x plus some constant. My slope, the slope is going to equal my gravity divided by 4 pi squared. So to find gravity, it's going to be 4 pi squared times my slope. And that should equal whatever value you calculate. This is your measured gravity. You're going to want to do a percent error of that value times 100%. So the experiment is actually fairly easy. You're just going to need a string with some weight on it, and it could be your keys. It could be anything with a weight on the bottom. You can use a piece of string. You're going to have to measure the length because you're going to need your length. You're going to do it for at least 3 different lengths. You're going to determine your average period, and remember that your period goes over and back. That's a complete swing. And because we want to do 10 swings, because it's very hard to measure just one. So you're going to get your average for one swing, and then you're going to get your average for your individual length. You're going to create a second data table that's going to give you your length and your period squared. You're going to do a graph with your length on the y-axis and your period squared on the x-axis, because my line now becomes y is my length, and this would be like my 1.63 times my period squared. And there's our equation for our line. So that's how we know what our slope is. And you're going to determine gravity from the slope. I'm only wanting to see one calculation for gravity. And that's using your slope. And then you're going to use your percent error with the real value being 9.81 meters per second squared. And your slope, if my L is in meters and my periods in seconds squared, we know our slope is in the correct units. So that is your pendulum lab. Hopefully that will get everybody a pretty good idea of how to do that laboratory. Questions?